You see that? There, yeah. So 96. So we'll say 80 to the first arc, 96 to the bottom. So I'll draw that up properly and get myself a proper, accurate volume in that. But I think it worked out at about 5.5 litres. But I think these caps are a little bit bigger than I drew originally. So I'll work that out in a minute.
Right, so what I was just showing there was the variable tank parts that have arrived. So I mean, I've drawn it up, but there's not really much to show about that. There's the pipe and there's a couple of caps. But what is interesting is the boundary fill that I just did. So I just move it. So that's the internal volume. And I've worked that out to be computers worked it out to be 6.3 litres. So I'm going to have, with one at the front, one at the back, that's 12.6 litres. So let's say 12.5 litres. So I've got 12.5 kilograms of weight to adjust the buoyancy, which isn't a lot. So I'm going to have to be really on the ball with it. And the other thing I was just saying in the video was I was showing the overpressure valve, which is this that I was making. So the idea with this is this body part welds into the hull, and then it's very simple. There's just a spring loaded rod that goes through and an O-ring seal. So if this will be on the inside, if you get a overpressure situation, so the boat is become at higher pressure than the pressure outside due to like an air leak inside, this top will just pop off with pressure and just release that pressure, and then should spring back down again. And you can adjust the spring tension with this wing nut. But what I was gonna show, I did show me machining this on the rotary table, but I lost all footage, so it's sort of jumping straight into me finishing it off on the lathe. But I did start it all off in the mill on the rotary table, and I've done all the drawings for it as well. So there's the sort of assembly drawing, and then the cap. And this is what I was also saying in the video, is the whole point of me doing it slightly different this time, is that I wanted this surface and this surface to be machined all in one go. And I did do that on Jodie B, but what I didn't do is I didn't do this weld. So Jodie B's is just screwed in, but what I want to do on this one is I actually want to weld it at the top like that, and then machine over the top of the weld. So that red part there shows the weld, and that is because I want it all to be one integral part. And then the last drawing, where is it? Yeah, that's the valve body, so it's fairly straightforward.
Okay, last one this. Okay, so I'm just going to quickly flick back to the 3-jaw, face this surface and the other surface, break these edges, then this is the base done, and then I can start on the cap. I'll just get these last little burrs out of this pipe deburrer thing. Okay, so that's the base. So now I've got to make the cap. I've got to be careful not to damage this surface. So this is just drilling it out, 14.5 I'm going all the way through. Once you get your mojo on the correct feed rate, then it goes quite easy. Well, right, so I didn't really want to have to do this, but I could have sworn that I had an M16 by 1.5. I could have sworn I had a 1.5 tap by M16, but I haven't got one. So I bought this. I bought this bolt, which was going to do the job for me and save me having to do this. But I didn't have the one I've got is M16 by 1.5, and I need by 2. I think, is that right? Oh, something like that. The one I need is M16 by 1.5. Oh, look at that. 16.005. Right, anyway, so threads. Let's line this up now. Make sure we're using the right one. Can't quite get in there. God, everything's awkward. So I've got this little tiddler of a live centre for just this sort of awkward situation. Right, is that enough for me to get the thread cutting tool in? Hopefully it is. It's very close. Yeah, it is. Okay, it's real close, I tell you. Set this up again. So metric 1.5 is LS6Z. So I've engaged the thread chasing dial. In fact, what I'm going to do, actually, I've changed my mind. I'm going to just offset the cross slide here. Okay, I'm going to go at number 1. Right, so I got 2 ways of doing this. I'm going in on number 1 on my thread chasing dial, and I'm going to put in my cut, which is, I'm at 28-ish something degrees, and I'm going to go in 0.1 of a millimetre of a cut. Half nut is engaged. I'm in forward, and I'm cutting my thread. Now what I'm going to do is just come quickly out of the groove and the half nut is still engaged, so I'm just in reverse now. I'm just going to wind back. It's a bit boring waiting for it to come back because I'm actually cutting at a really slow speed. Right, so I'm going to now go another 0.1 of a millimetre, half nut still in. Right, so this is the other way I'm going to do it this time. Disengage the half nut, so I'm out of gear. Coming back to. And now what I'm going to do is I'm going to come back round in reverse, and I'm going to re-engage at number 1. And that should be back in the same position. Taking it out, so there's nothing. I haven't got anything that I can test it with. I haven't got any thread gauges, thread gauge wire, so I've had to sort of guess the depth a bit. Let's see if it's going to fit. I don't want this much on it. Parting tool makes a nice finish. It's as good as facing off. Nearly as good. Right, power tap. Worked out how far through it has to go. About there, I think. What do you think? My bet is no. No, it's too tight. It's back in, I think. So I'm just gonna see that's actually in the right place. Right, so I've re-picked up the thread and I've done a couple more passes, and I've also knocked the top off of this slightly because I felt my outer diameter was a bit too much, and I've got, now it fits. As you can see, now just mangle up all my really nice threads I just did. Right, so the whole point of this is that that bit welds into the hull. This bit now screws into there, and what I'm going to do is weld down in there, in that hole that's now there, and I'm going to weld that so this bar is never going to come out, and they're now one complete unit. On Jodie B, this piece here is just screwed in, and it always just worries me. Somehow it might just wiggle its way loose. It's extremely unlikely, but this is the way I've wanted to do it with this. So what I'm going to do is just going to put a chamfer on this now at about, I don't know, what, 60 degrees or something. Put a chamfer, I'm going to weld in the top of there, put a chamfer on. Then with the whole thing all chucked up in the machine, I'm going to then turn this down to exactly the same bore as that, which is 12mm. And that will, this must be completely at 90 degrees to that. Right, so the whole point of this was that I wanted to make this and this one complete unit, so that when it fits through here, this is accurately machined to the surface of this, and also this bolt is actually integral to this, so there's no way that it could come off. If the Jodie B's is just screwed in, and it's very well screwed in, but I just always a little niggle. If that top of that valve came off, you'd have a hole through in the hull. Anyway, so what I'm going to do now is I'm going to weld down inside of there. I'm going to machine this at a little bit of an angle, that's that tapered angle, and then I'm going to machine this down to match that 12mm, because I want that to be a nice fit.